Okay, and we're back. So we're in part C. Since I kind of scribbled all over my part A, I'm going to come over here to do part C. So it says to write the equation for the tangent line at the point you found in part A. Since we found 2 points, I'm just going to choose one. So I'm going to pick this one. Okay, you can do both if you want to, but I'm just going to pick this one. Okay, because I don't want to have to write 2. So remember, your homework is just about practicing. It's not a big deal. So dy dx at 1, negative 2 would be 3 times 1 squared, negative 2 minus negative 2 squared, over 2 times x is 1, y is negative 2, minus x here is 1 cubed. So from there, I'd have 3 times 1 is 3 times negative 2 is negative 6. And then here, if that's a negative 2 squared, that negative on the inside is going to cross out to be a positive 4. But this negative out here does not cancel out. So it is going to be a minus 4 at the end. Then on the bottom, 2 times 1 is 2 times negative 2 is negative 4. And then we have minus 1 more, so that'd be negative 10 on top, negative 5 on bottom, which is 2 for my slope. Then from there, I would write the equation of my tangent line. So remember, I'm choosing this one, so it'd be y plus 2. 2 is my slope, x minus 1. Okay? Great. All right, so hopefully that wasn't too bad. Go ahead and turn the page, please. The other question I was going to do with y'all is number 12. Okay, and number 12, the number one mistake I usually see people trying to make on this one is that they think that this is a quotient rule problem. Okay, if this is a number on the bottom, that's not quotient rule. You only need quotient rule if you have like x squared over sine x, or x squared over y, or something like that. But if it's just a 32 on the bottom, you can just rewrite that as 1 over 32 x squared, and then 1 over 8 y squared, and then 1. So that's fine. I would just do a rewrite. This is not a quotient rule type problem. Okay, so I'm ready to take the derivative. 2 multiplies down on 1 over 32. Now it's 2 over 32x. Notice it used to be squared, now it's to the 1, plus 2 multiplies down, now it's 2 over 8. Y used to be squared, now it's to the 1 times dy dx, equal to derivative of 1 is 0. Okay, from there, I'm going to move this term across to the other side. I'm also going to reduce these, so 2 out of 32 is the same as 1 over 16. Okay, and then 2 over 8 is 1 over 4. So I'm going to go ahead and do that next. So I have 1/4 y dy dx, and then 1 over 16 x negative on the other side. From there, to get rid of the 1/4 and the y, I'm going to multiply the other side by 4 over 1 y on the bottom. Okay, and the reason that I'm doing that is 4 over 1 y is because that's the same as dividing, but rather than dividing by this as a fraction, I'm going to just think about like multiplying by the reciprocal. So 4 on top, 4 on bottom, those are gone. 1 y on top, 1 y on bottom, those are gone. So my dy dx is going to be negative 1 over 16 times x times 4 over 1 times, oops, y was on the bottom. Okay, now let's clean that up a little bit. So 4 over 16 can reduce. 4 over 16 is the same as negative 1 over 4, and then my x is on the top, my y is on the bottom. So that's my slope at any point. Okay? Now, if you solve that a little differently, but you got the same answer, then who cares, right? It's still good. Okay, from there, we want it at the point 4, 2. So I would put dy dx 4, 2 equals negative 1 times 4, 4 times 2. Negative 4 over 8, which is the same as negative 1/2. And that would have been your answer there. Okay, next one that we're going to do, I'm going to actually start number 13 because it's a second derivative. So this is going to be my u, this is going to be my v. So my u is going to be 2x, my v is going to, 2x to the 4th, and my v is going to be y squared. So my u prime is going to be 4 times 2 is 8, x is now to the 3. My derivative here is going to be 2y dy dx. Okay, from there we're going to do our product rule. So it's going to be 2x to the 4th times 2y times dy dx, that's this diagonal, plus 8x cubed y squared equals derivative of 8 on the other side is 0. Take this term, move it across to the other side. Remember that it used to be positive, so now it's negative. On this side, my dy dx is going to come out to the front, and then I'm going to go ahead and combine these. 2 times 2 is a 4 in the front, then x to the 4y. And then remember, what I want to do with that is divide it to the bottom here. Okay, and then remember, once I divide it, I need to cross it out on this side so that it's not still there. Now, I don't want to leave my dy dx like that. That looks pretty ugly. So if I have x's on top and on bottom, I'm going to reduce, and if I have y's on top and on bottom, I'm going to reduce those as well. So my dy dx is going to be negative 8 divided by 4 is negative 2. I have an extra x left over on the bottom. I have an extra y left over on the top. Now, knowing that I'm going to have to go to d squared y dx squared, I'm going to go ahead and find that at this point. So, before I find the second derivative, I'm going to find the derivative at 1/4. So it'd be negative 2 times 4 divided by x is 1 is negative 8. Okay? So there are two things that I need to go on to the second derivative. I need this formula, and then I need to know what the slope is at that point. If you don't remember why, you're going to see here in a minute. Okay, so let's do our quotient rule now. This is going to need quotient rule. So my high is going to be negative 2y. My ho is going to be x. My d high is going to be negative 2 times y is negative 2 dy dx. My d ho is just going to be a 1. So when I take the derivative of this again, I'm going to get d squared y dx squared equals, and then it's going to be ho d high, so x negative 2 dy dx minus high d ho negative 2y, and I'm not going to put the 1 since it doesn't matter. Okay, then divide by ho squared is x squared. The only real change that I'm going to make in the way this is written is I'm going to switch those to pluses, just because if it's a double negative, we know those are going to cancel out. So then now I want dy dx, or the second derivative, at 1,4. So remember, there are three things I'm plugging in here. My x is going to be 1, my y is going to be a 4, and my dy dx is going to be the negative 8. Okay, hopefully that makes sense. So my x is going to be 1, negative 2 times negative 8, 2 times y is a 4, and then my x is a 1 squared on the bottom. Negative negative crosses out, that's really just a 16 times 1. 16 plus 8, divide by 1, 24. So that would be your second derivative at that point. Okay? Alright, now the one other question that I was going to do for you is number 5. So if you'll flip back to number 5. I crossed out the graphs on the front, so that's why there's like a weird X in the middle of my paper. So my derivative here, I'm going to so it says find any points where the graph has a vertical or a horizontal tangent. So remember, that means I'm going to take the derivative. Vertical, I set the denominator equal to 0. Horizontal, I set the numerator equal to 0. Now, when we're talking about denominators and numerators, we mean of dy dx, so that's what we have to do first. So, 2 multiplies down to the front, that's 2x plus 2. But then the derivative of x plus 2 on the inside is just times a 1. So there is some chain rule there. Okay? Plus, second one, I bring my 2 down to the front. Y minus 3 is now to the 1 power because it used to be squared. But then I have to multiply by the derivative of the middle, which is dy dx. Remember, the derivative of minus 3 is just 0. Okay, other side equals derivative of 9 is 0. From here, this term is going to move across to the other side. So I'm going to have 2y minus 3 dy dx equals negative 2x plus 2. Then I'm going to divide this to the bottom. And then hopefully you're okay with the fact that since there's a 2 on top and a 2 on bottom, I can rewrite my dy dx to be x plus 2 over y minus 3, negative in the front. Okay, from there, we want horizontal and vertical tangents. I'm going to do vertical first. Remember, for vertical, I set the denominator equal to 0, so that would be y minus 3 equal to 0, which means that y is 3. Now, they are asking me to find points. Remember, for a point, I use the original. So I'm going to come back to this junk right here, and I'm going to plug in 3. So it would be x plus 2 squared, 3 minus 3 squared equals 9. But 3 minus 3 squared, we know that's 0. So really it's just x plus 2 squared equals 9. Square root both sides. I get x plus 2 equals plus or minus 3. And then from there I'd minus 2 here, minus 2 here. So my x's are negative 2 plus 3. Well, that would give me 1. So negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. So it'd be 1 comma 3 and negative 5 comma 3. Those would be my 2 vertical tangents. Okay, second part, we need our horizontal tangents. So remember, for horizontal, I'm setting the top equal to 0. Negative x plus 2 equals 0. This is already factored for me, so x is negative 2. Then I would have to go back to my original here, and I'd have to plug that in. Now, a very similar thing is going to happen this time that happened last time. Negative 2 plus 2 in here is going to be 0. Y minus 3 squared equals 9, so that cancels out. And then I would square root both sides. So square root. And I get y minus 3 equals plus or minus the square root of 9 is 3. Then to get rid of this minus 3, I would add 3 and add 3. So 3 plus 3 is going to give me 6. And 3 minus 3 is going to give me 0. Now remember that these are y values. So when I write my ordered pairs, sorry, I'm going to have to write down here. It's going to be negative 2 comma 6 and negative 2 comma 0. Okay? Now, mainly I want to talk about this last part here. So it says, sketch the graph to check your work. And then it says, think conics. You should have covered conics in Algebra 2. Conics is graphs of circles, ellipses, hyperbolas, all that stuff. So I'm just going to remind you of the equation of a circle. And this is pretty old school, but you should have learned it. It's x minus h squared plus y minus k squared equals r squared. That is a circle that is centered at HK, and R is your radius length. So if I want to sketch a graph of this, okay, I'm going to have to find my center first. So if it's 2 and negative 3, since there's negatives built into the formulas here, the center of my graph is going to be negative 2. Negative 2, comma, positive 3. And my radius is going to be the square root of 9, which would be 3. So I'm going to sketch a little graph over here. Remember, this is only to check your work. The AP test is not going to require you to do this. This is just to kind of remind you of some stuff you should have already learned. So if this is my graph, negative 2, and then 1, 2, 3, that puts me right here. That's my center. And then I'm going to count a radius of 3 in all directions. So 1, 2, 3, put a dot. 1, 2, 3, put a dot. 1, 2, 3, put a dot. And then 1, 2, 3, put a dot. Then remember, this is the equation for a circle. So there's my circle. And now I want you to think about the vertical and horizontal tangents. Horizontal lines are flat. So if I look at my flat lines, I said they occur at negative 2, 6 and at negative 2, 0. Well, look. Negative 2, 6 is here. Negative 2, 0 is here. And notice that at those points, if I draw my tangent line in, it's flat and it's flat. So those are both my 0 slopes at the top and at the bottom of the circle. Okay, now let's talk about my vertical slopes. Okay, my verticals occurred at 1, 3 and negative 5, 3. Well, here's 1, 3, here's negative 5, 3. And if you think about the slope at those sides of the graph, well, my circle's perfectly up and down. That's a vertical slope. That's a vertical slope. Okay? So that second part of the checking is just to kind of remind you of stuff you should already know. If you could get through the math here and just following the processes we've talked about, that's the main thing. Okay? All right, good job. I'll see you guys on Tuesday. Good luck.